Hello, Year 11, and welcome to our 12th topic here for the graphs. We're going to start with graphing reciprocal functions. Now, the hyperbola is our basic reciprocal function, our sort of standard one, and these graphs are generally going to share some of those characteristics, like the vertical and horizontal asymptotes. Not always, but mostly. The best way to do these is to begin with a sketch of the function, right? Then we're going to draw the reciprocal of that. But a couple of key points to sort of mark on these graphs. If my original function crosses the x-axis, if the function is equal to 0 somewhere, then the reciprocal of that is undefined. So we get a vertical asymptote there. Where my function is between 1 and 0, where my function is positive, my reciprocal is positive. Where my function is negative, my reciprocal is negative. When it's increasing, the reciprocal will be decreasing and vice versa, and a few other little bits and pieces too. So when it's greater than 1, my function is greater than 1, then my reciprocal is less than 1. Where my function is between 0 and 1, my reciprocal is greater than 1. Okay, all of that talk makes a lot more sense, I think, once we've had a look at a graph. So this is a very simple function to begin with, y equals 3 minus x. And from there, we're going to sketch y equals 2 over 3 minus x. Now, the 2 is a bit of a red herring there. Don't worry too much about that. So here's my axes, and there is the function y equals 3 minus x. Of course, it's linear with a gradient of -1 and a y-intercept of 3. So that should be everything we need labelled there. So the reciprocal. Well, between 1 and -1, important things happen. And apart from anything else, will intersect at those points. Righto? So we'll have an intersection here and here. Also, I want to put in this little sort of construction line. Now, those lines there, the -1 and 1, they're not asymptotes. I've just drawn them in there because they'll help me with my construction. But this line here, x equals 3, is an asymptote. So you see there is a 0 of this function here, right? My blue line here, my linear function, crosses the x-axis at x equals 3. So I want a vertical asymptote there. Righto. So on the left-hand side here, we can see we intersect, right, at where my function is equal to 1. The reciprocal will also be equal to 1 over 1. And as this gets close to 0, my reciprocal gets close to infinity. As my function, away here on the left, the negative side, as that continues to increase, my reciprocal continues to approach 0. It doesn't keep getting smaller. Well, it keeps getting smaller, but not without limit. It just moves towards 0 because I end up with 1 over a really big number. Now for the part here on the right, now my function will be negative, so my reciprocal is negative. It has to pass through this point here, right, where my original function crosses the line y equals -1. Right. So we've got a horizontal asymptote here, a vertical asymptote here. That's the reciprocal. Now, as for that 2, really just sort of has something to do with the steepness of the graph. If I draw 2 hyperbolae over the top and I multiply 1 by a constant, it's hard to see the details of that in the graph. Right? One over the top of the other, we see a difference, but nothing much when we go to sketch them. So don't worry too much about that 2 up there. Righto, that's a good start. Here is another graph here. I don't have the equation for it this time, just a graph, and I want to draw the reciprocal here. So I could draw these lines across here at y equals 1 and y equals -1, but because I've got the graph there already, the grid lines already, that's pretty clear. But I do want to quite specifically put in my vertical asymptotes here at -1. At 1, there should be 1 there at 0 as well. But again, you know, my y-axis is pretty clear there, so I'm not going to draw over the top of it. So I have 3 vertical asymptotes where my function is equal to 0, the roots of that function there. Now over here, my function is positive. It needs to intersect here at the 1 and then approach 0 as we move off to the left. Right, so there's that part there. So vertical asymptote here, horizontal asymptote there, intersects when the function is equal to 1. Now, here my function is negative. Between -1 and 0, my function is negative. So I'm going to have this sort of a bit like a concave down parabola. It's not, but nonetheless a curve there that goes up and down again. It should be, right, the peak there, that's looks like it's at -2/5. So it should be the reciprocal of that, -5/2. But that's just not going to fit on my graph, so I've drawn it somewhat inaccurately here. That maximum there, that local maximum there, should be all the way down here at the reciprocal of that maximum there, but it just doesn't fit very well on this particular sketch, so we'll have to live with that one. Similarly, here, my function is positive, so my reciprocal is positive. I've got asymptotes on either side, right, as my function, my original function, is close to 0, my reciprocal will approach infinity. Again, that's 2/5, so it should be 5/2, it should be 2.5 up here somewhere, but it just wouldn't fit on the page. And one more little section here, my function is negative, so the reciprocal is negative, should cross here where my function is -1, with a vertical asymptote here, and a horizontal asymptote over here. Let's see how that looks. Yeah, not the smoothest curves in the world, but not too bad. Okay, so that's sketching a reciprocal function over the top of another one. That's a pretty good way to do these things, right? Rather than algebraically, I think if you've got a sketch, if you can make a sketch, that's a good way to go. And that's the most common way for these questions to be asked as well. Here we have what would seem to be the sine function, y equals sine of x. And you can see this varies, of course, from 1 to -1. My range is from 1 to -1. And that's good. The maximum's there, so that means that I should just touch at 1 and -1, because the reciprocal of 1 is 1. The reciprocal of -1 is -1. I have zeros at 180 and 360, as well as 0 there. So there are my asymptotes. Oh, I've jumped along way too far. Sorry. Hold on, let's come back. Oh, I'm on the wrong, hang on. That's a bit sloppy. I clicked on the wrong page. Now, we should be able to put a curve in here now, I hope. So there we go. Asymptotes, vertical asymptotes at 0 and 180. And just touches here like a tangent, sort of, except it's not a straight line, at 90 degrees when it's equal to 1. And we'll get the same thing down here at the negatives, and it would just keep repeating on and on, right on either side, because this is a periodic function. Rightio. That is graphing reciprocal functions. A couple of things to remember. Where there are zeros in my function, I have vertical asymptotes for the reciprocal. Both the function and its reciprocal are equal when y equals 1 and y equals -1. So that's an important little point, especially when you draw one over the top of the other. Right? You should have those intersections in the right point. When one's positive, the other is positive. One's negative, the other's negative. That should do us. Okay, reciprocal functions. If you've got any questions, please make sure you jot them down, ask me in class. Otherwise, I will see you in our next video, which is graphing square root functions. It is exciting. I'll see you then.